Hey everyone, and welcome to the channel. This is the place to be for all things tech, especially when it comes to understanding the systems that power our digital world. We will break down the complex topic into easy to understand. In this video, we will be examining the fundamental structure of an operating system. We will begin with an introduction to the key components that make up OS and the explore various architectural approaches, highlighting their strengths and weakness. This video is perfect for students, developers, and anyone curious about how operating system functions. This slide defines what an operating system and uh, what it does. In short, the OS is the fundamental software that manages all the hardware like CPU, memory, storage, and software resources like files and programs of a computer. It acts as a bridge between the user and the hardware, providing way for users to interact with the computer. Finally, the OS make it possible for applications like uh, web browser or games to run by providing them with necessary service and resources. This slide outlines key functions of an operating system. It says of OS is responsible for process management, memory management, file system management, security and protection. The process management deciding which programs run when and actually running them execution. Memory management managing the computer's memory including allocating it to programs and taking it back when they are done. Next, file system management. Organizing files and folders and controlling how programs access them. Last one, security and protection. Ensuring the system is secure by verifying who can access it and what they are allowed to do. This slide describes some important components of an operating system. First one, kernel. This is the heart of the OS. It is the core responsible for the most fundamental operations like managing CPU, memory, and hardware interaction. Think of it as the brain of the OS. Next, system calls. These are how programs communicate with the kernel. When a program needs to something, the OS handles. It makes system call to request the kernel service. They are defined way for program to ask the OS for help. Next, file system. As mentioned before, this component is the charge of organizing files and folders on the storage device and providing ways for program to access and manage them. Device drivers. These are small programs that allow the OS to communicate with specific hardware devices like printers, keyboards, or graphic cards. Each device needs its own driver so the OS knows how to talk to it. This slide describes the monolithic operating system architecture. It means the entire OS is built as one single massive program. All the different parts of the OS like memory management, file management talk to each other directly. The good side is that this can be very fast and efficient because everything is so interconnected it becomes very complex, making it hard to make changes or fix problems without risk breaking other parts of the system. This slide describes the microkernel operating system architecture. Unlike monolithic kernels, microkernels keep only the most essential OS functions like process management, basic communication in the kernel itself. Most other OS services like file system and device drivers run in user space. Separate from the kernel, this approach offers advantage. It's more secure because failures in one service are less likely to crash the whole system. Modular, making it easier to add or remove features, and extensible, allowing for easier customization. The downside is that communication between the microkernel and the user space service can introduce more overhead, potentially leading to slightly slower performance compared to monolithic systems. This slide describes a layered operating system architecture. The OS is organized into distinct layers where each layer provides specific service and only interacts with the layers directly above and below it. This structure makes debugging and maintenance much simpler because changes to one layer don't affect the other non-adjacent layers as much. However, a potential drawback is that requests might have to travel through multiple layers to be fulfilled. which can add overhead and potentially reduce the performance. This slide describes modular kernels. These kernels allow the parts of the OS called modulars to be loaded and unloaded on the fly while the system is running without needing to reboot. This provides great flexibility and extensibility because you can add new features or device drivers as needed and remove them if they are no longer required. The major advantage is that you don't have to restart your computer to make these changes. The trade-off is that managing these modules can become complex as the OS need to keep track of dependencies and ensure that interact correctly. This slide describes hybrid kernels. These kernels try to combine the best aspects of monolithic and microkernels. They maintain relatively small kernel core like microkernels but include some key service like file system management within the kernel itself for performance reasons. Similar to monolithic kernel, this approach used into popular operating systems like Windows and Mac OS aims to strike a balance between security, a strength of microkernel, and performance, a strength of monolithic kernel. However, the resulting design is more intricate and complex than either of the pure architectures. This slide explains virtualization. Virtualization lets you run multiple operating systems simultaneously on a single physical machine. It uses hypervisor, which is the software layer that manages these virtual machines. There are two main types. A hypervisors called bare metal run directly on the hardware, while type 2 hypervisors hosted run on top of an existing OS. Virtualization is widely used in cloud computing to share resources and the testing environment to easily create and manage different system configurations. This slide describes process management, a key OS function. The OS is responsible for creating, scheduling, and terminating process. It uses CPU scheduling algorithm to determine which process gets to use the CPU at a given time. Context switching is the mechanism that allows the OS to smoothly switch between different processes, creating the illusion of multitasking. Finally, the slide mentions process states which track the life cycle of the process from its creation to its completion, with intermediate states like ready, running, and waiting. This slide describes memory management. The OS manages the computer's memory, allocating it to process when they need it and taking it back when they are finished. It uses techniques like paging and segmentation to efficiently organize and utilize memory. Virtual memory creates the illusion of having more RAM than physically available by using disk space as an extension of RAM. Swapping is the process of moving inactive or less frequently used parts of process from RAM to the disk to free up memory for other processes. This slide covers file system management. The OS is responsible for organizing files and directions on storage device in an efficient way. It also provides access control and security mechanism to protect files from unauthorized access. The OS supports various file systems, which are different ways of organizing and managing files. Finally, the OS implements common file operations like reading data from files and writing data to the files and deleting files. This slide explains I/O management. The OS handles communication with all the input and output devices connected to the computer. It uses techniques like buffering, caching, and spooling to optimize input-output operation. Device drivers are specialized software components that allow the OS to interact with specific hardware devices. The overall goal is to ensure efficient and reliable data transfer between the computer and its peripherals. This slide describes security and protection in operating system. The OS is responsible for maintaining the system's integrity and confidently it achieves this through various mechanisms including user authentication to access the system often with username and passwords, encryption make it unreadable without a key, and access control list and permissions defining who can access what resources and what they are allowed to do with these resources. This slide is about how user program talk to the operating system. The OS provides an interface, a defined way for program to request service. These services fall into categories like process control, file management, and device management. Common examples of these interactions are functions like open, read, write, file. Crucially, this interface ensures that programs can only access OS functions in a controlled way, preventing them from doing things they shouldn't and maintaining system stability. This slide describes how users interact with the operating system. It highlighting two main types of user interface. Command line interface. Users interact with by typing commands directly into the terminal or console. This provides powerful and direct control over the OS. Next is graphical user interface. Uh, Users interacts using visual elements like windows, icons, and menus. This is generally considered easier to use, especially for beginners. To shell is the program that interprets the commands entered by the user in the CLI. Examples of shells include Bash, powerful Windows, and the command prompt. This slide describes Linux. It tells us the Linux has monolithic kernel, meaning most of the OS functionally resides within the kernel itself, but it uses loadable modules which allows for flexibility by adding or removing features without requiring a reboot. Programs interact with the kernel through system calls. Linux supports to wide variety of file system. Um, for managing files and directories. Finally, Linux is known as its strong security feature and fine-grained permission controls, allowing for precise management of access to the system resources. This slide describes Windows. It has a hybrid architecture, meaning it blends elements of monolithic and micro-kernel design. Applications interact with the system through system APIs. Windows primarily uses the NTFS file system, which includes robust security features. It supports multi-user capabilities, allowing multiple people to use the same computer simultaneously, and a networking feature for connecting to other computers. In conclusion, it emphasizes that different OS structures are designed to meet varying needs. Modern OSs like Windows often use a hybrid architecture. Current trend is OS development include modularization, more flexible by adding or removing components, and virtualization. Cloud computing and AI are also influencing OS development, with cloud-based OSs and AI-driven optimizations becoming more common. Finally, it stresses that selecting the right OS depends on the specific requirements of system it will be running on. Thank you, guys.